Welcome all the students in Airforce special for upcoming examinations. Let us discuss about few questions regarding to the Airforce examination. Let us discuss about optics today. The questions are, what does it mean by light? What is light? Light is a form of energy which when fall on any surface will get rebound and produce the sensation of vision on the retina of eye. Light shows optical effect, and by the concept of reflection, one can see the light or objects. To see any object, two things are essential. First is light, second is human eye or eye. Now, let us start the questions. Question number first, what is nature of light? The nature of light is transverse. Remember, it is transverse nature. Then, what is speed of light? Speed of light is c is equal to 3 into 10 to the power 8 meter per second. This is speed. Remember, it is very important question that light can travel through vacuum or not. Yes, light can travel through vacuum. Other question is, what is speed of light? Whenever it is traveling in a medium, then speed of light c dash will be equal to c upon mu. In the case of medium, speed of light decreases. Now, what about the refractive index? Refractive index is ratio of speed of light into medium, that is mu is equal to c1 upon c2. Refractive index is a quantity which is unitless and dimensionless. Now, let us discuss about reflection. Whenever there is a surface on which light is falling and this light will get rebound in the same medium. The questions are, what about angle of incidence and angle of reflection? Remember, angle of incidence is always equal to angle of reflection. The question is, what is change in frequency, speed and wavelength? The answer is, there is no change in frequency, speed and wavelength during reflection of light. Now, another question, reflection from plane mirror. Whenever a light fall on plane mirror from a certain object, the distance of object is always equal to distance of image. Remember this thing. Distance of object is always equal to distance of image. Second is, if object is moving with certain velocity, then image will also start moving with that velocity. Then what about relative velocity? Relative velocity will be 2 times of the individual velocities. Now, what about the nature of image with respect to object? The image will be laterally inverted. Then, what about the magnification of plane mirror? In the case of plane mirror, the linear magnification m will be +1. Then, what about the size of plane mirror so that one can see his complete image? If a Sarah is standing here and he want to see his complete image, then he require at least half of his length. The size of mirror should be, if he is of height h, then size of mirror should be h by 2. Then the question is, how many alphabets of capital letters are seen to be erect in a plane mirror? And these alphabets are A, then I, then H, then M, then O, then U, then V, then T, then W, then X, then Y. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. These are the 11 alphabets which can be seen erect. Except them, all the capital letters will get inverted. Now, what about the nature? These will be laterally inverted. Not exactly reverse, but laterally inverted. Then the question is, how many images are formed when 2 plane mirrors are kept at certain angle theta? Remember, to find out the images, first of all find out 360 upon theta. If it is even, then number of images will be 360 upon theta minus 1. This will be about number of images. Numerical can be, if angle between them is 90 degree, then 360 upon 90 will be 4, which is an even number. Then number of images will be 4 minus 1, that is 3. Now the question arises that if it is not even and if it is odd, then take the position. If object is on the equatorial line, then there will be 360 upon theta minus 1, and if at any other place other than equatorial line, then number of image will be 360 upon theta. Now the question is, if 360 upon theta is found to be in decimal p point q, then number of images are taken in whole number, that is p only, not q. Q is not taken in consideration. The number of images will be shown by p only. If two plane mirrors are mutually parallel, then how many images are seen? If a Sarah is standing in between them, he will find that he is having how many images? He is having infinite number of images, because theta is 0 here, 360 upon 0, that will be infinity, and hence infinite number of images are seen. Now, what about reflection through spherical mirrors? If there is spherical mirror which can be either concave or convex, then two things are very important. First, about the light rays which are parallel to the principal axis, it will essentially pass through the focus. Light ray which is passing or appear to be passing through focus will become parallel after reflection. This is very important. Now the question arises that which kind of images are formed. This is an important question. Whenever you consider about concave mirror has tendency to converge the light rays, so it is also known as convergent mirror. Whenever you see concave mirror and the images, then you will find that the images can be real, can be virtual, can be erect, or can be inverted. But in the case of convex mirror, the images will always be virtual and erect. In general, all the virtual images are erect. Now, what about the numericals? There are two kinds of formulas on which numerical can be asked. First is relation between focal length and radius of curvature. That is, r is equal to 2f or f is equal to r by 2. Now, the second is mirror equation or mirror formula, that is 1 upon f is equal to 1 upon v plus 1 upon u. Remember, positive sign is there. U is distance of object, v is distance of image, f is focal length. The sign conventions are essential whenever we are going for the numericals. Sign conventions. All the distances should be measured from pole. If it is a mirror, all the distances should be measured from pole. Distances along incident light are taken to be positive. Distances opposite to incident light are taken to be negative. Heights above principal axis are taken to be positive. Heights below principal axis are taken to be negative. So this is very important. Now, what kind of questions? If we see that there is a concave mirror, an object is situated at distance 40 centimeter, focal length of mirror is 10 centimeter. What about the image? It is very clear the image will be in this side. U, that is distance of object, should always be taken negative, remember. So it will be minus 40. Focal length will be negative because it is opposite to the incident light. So f will be minus 10 centimeter. Take the formula, 1 upon f is equal to 1 upon v plus 1 upon u. 1 upon minus 10 is equal to 1 upon v plus 1 upon minus 40. By solving this, you will get the result. This will be the value of v. Now, other kind of questions based upon the height of object and height of image. If we consider about magnification, then it is ratio of height of image to that of height of object. Linear magnification can be considered m is equal to v upon u. It can be positive or negative depending upon the condition. V is distance of image, u is distance of object. Now let us discuss about refraction. When light ray travel from one medium to another medium, it will get deviated from its original path will get bent either toward or away from the normal. If it is moving from rarer medium to denser medium, it will bend towards the normal, and if it is moving from denser to rarer, then it will move away from the normal. Here, if R less than I, then second medium is denser. If R greater than I, then second medium is rarer. Now what about the change in speed, etc.? During refraction, whenever light ray is moving from one medium to another medium, the speed will decrease. V dash is equal to V upon mu. Lambda, that is wavelength, will decrease. Lambda dash is equal to lambda upon mu. Then the frequency that will remain same, it is not changed at all. Now the question is, what is application of it? A numerical can be asked. If there is a bucket full of water and a Sarah is going to see in the bucket, he will find that the bottom of the bucket will get raised up to a certain height. This raise in the bottom is supposed to be delta H. Original height up to which liquid field is H. Apparent height or depth, you can say H dash, will be H upon mu. Mu is refractive index. If you want to find change, then delta H will be H into 1 minus 1 upon mu. It is also very important whenever you have to find such. In general, take refractive index of water 1.33 and take the apparent height or apparent depth. Now, the other thing is, what is cause of twinkling of stars? This is also due to refraction. The other question is, what is cause of delayed sunset and early sunrise? It is also due to refraction. It is of 2 minutes early and 2 minutes delayed. So the day will be 4 minutes longer than actual length. Now, what about the lenses? Question can be based upon lenses like this. If this is a lens, it is said to be convex. This is another kind. It is said to be concave. The question can be, what is the deviation of light when it passes through center of curvature? So remember, there is no deviation. Now, the question is, what is focal length of convex lens? It is always positive. What is the focal length of the concave lens? It is always negative. What about the images formed by convex lens? Remember, images formed by the convex lens can be real, can be virtual, can be erect, can be inverted. But in the case of concave lens, the images will always be virtual and erect. Now what about the lens formula? 1 upon f is equal to 1 upon v minus 1 upon u. Now how the lens can be formed? To form lens, three things are essential. One is refractive index, second is radii of curvature R1 and R2. Then there will be a formula, that is lens maker's formula. 1 upon f is equal to mu minus 1, 1 upon R1 minus 1 upon R2. Now the question is that what will be effect on nature of lens when it is dipped in a liquid whose refractive index is more than refractive index of glass? Then remember, its nature will get changed. Now, if it is less, then nature does not change. But if these are equal, then it will behave like a plain glass plate. Light ray will pass straight and its focal length become infinite. These are few important questions. Then, what about the combination? If two lenses are there, which are kept at certain distance d, then having focal length f1 and f2, the net focal length 1 upon f is equal to 1 upon f1 plus 1 upon f2 minus d upon f1 f2. If these both are close to each other, then what about this? 1 upon f will be equal to 1 upon f1 plus 1 upon f2. The nature depend upon initial and final focal lengths. Now we discuss about prism. Prism is a structure having equilateral triangle of certain angle of prism A. When light ray fall on it, it will get deviated by certain angle. The angle of deviation will be delta, and it depends upon A, angle of incidence, I, angle of emergence, R. What about, angle of emergence E? What about this delta, that is angle of deviation, A into mu minus 1. But in detail, if you have to find, then delta will be I plus E minus A. Now what about A? A will be R1 plus R2 upon 2. What about A? The A will be A is equal to R1 plus R2. If the minimum angle of deviation is there, the question arises, what is condition of minimum angle of deviation? For this purpose, angle of incidence should be equal to angle of emergence. Then graphical representation in this way, if graph is drawn between angle of incidence and angle of deviation, then initially angle of deviation decreases and become minimum at this place, that will be delta M when I is equal to E. After that it will go on increasing. Now other question is, what about dispersion of light? Whenever light fall on a prism, it will get divided in 7 constituent parts. These are Vibgyor parts, and angle of deviation for each part will be different, as I am showing here. Starting from V to R, that is Vibgyor, mean deviation is yellow. The angle of deviation for red is minimum and angle of deviation for violet is maximum. For yellow color, it is mean deviation. Listen students, angular dispersion will be theta is equal to delta violet minus delta red. This can be represented A into mu violet minus mu red. Mean deviation takes in play whenever we have to find the dispersive power, that is omega is equal to theta upon delta y, and it will be omega is equal to delta violet minus delta red upon delta yellow, and its result will be omega is equal to, what about omega? That will be mu violet minus mu red upon mu yellow minus 1. Now the logical questions are, these are useful for numericals. Logical questions are, what is cause of the dispersion? The basic cause of dispersion is the variation in wavelength and causing the variation in the refractive index. Mu is equal to A plus B upon lambda square. It is formula based upon Cauchy's law. According to Cauchy, more the wavelength, less will be the refractive index. So increase the wavelength and reduce the refractive index. This is about the refractive index and wavelength relation. In this case, for red color, wavelength is maximum. That's why mu will be minimum. That's why delta will be minimum. This is the basic reason behind that. Now we discuss about optical instruments. There are basic 4 optical instruments. One is simple microscope, other is compound microscope, other one is telescope. Telescope is itself divided in 2 parts, that is reflecting and refracting. Let us discuss about the minimum distance of distinct vision, capital D. It is 25 centimeter. Let us discuss about maximum distance of distinct vision, and that is D infinity. Maximum distance can be infinity because one can see stars and moon clearly, which are situated very large distance. Now, what about simple microscope? It is a convex lens of short focal length. When object is kept before focus and optical center, then it will get refracted and it will create a virtual and wider image. Its magnification will be m is equal to 1 plus d upon f when it is obtained at minimum distance of distinct vision. But if it is obtained at infinity, it will be d upon f. Question arises that what should be the focal length? Its focal length should be short. Now, the other one is compound microscope. Compound microscope is having 2 lenses. One is objective and other is eye lens. Distance between them is managed by a tube, which is called tube of compound microscope. Now, what about the focal length? Focal length of objective should be short and focal length of the eye length should be large. Remember, focal length of objective should be short and focal length of eye length should be large. Now, the question is, if there is a lens which behave like objective, it is going to create a primary image, and then eye lens is going to create another image of this. Then final image will be highly enlarged and it will be magnified as minus VO upon UO 1 plus D upon FE. This is about magnification. Now, what about the telescope? Telescopes are in fact two types. First is refracting, other is reflecting. Refracting is also known as astronomical telescope. It has two lenses. Both lenses are convex lenses. The objective lens is having wider area, region and large focal length. Eye lens is having small area and region and short focal length. It will create a virtual image but inverted image. This telescope is also known as refracting telescope, and magnification, which is given as m is equal to FO upon FE, and length of tube as L is equal to FO plus FE. Both are useful in numericals. Like if m and L are given, you have to find FO and FE. Just make two equations, like m is given supposed to be 80 and L is given supposed to be 44. Then just put these values and get FO and FE. On the other hand, the other kind of telescope is a reflecting telescope, which is also known as Cassegrain telescope. It is having a big concave mirror, a convex mirror and eye lens. This is eye lens. This is concave mirror of high focal length. This is convex mirror of short focal length. Now, when light rays coming from infinite will get reflected by mirrors and get refracted by eye lens, and someone get the erect image. The question, what about the lenses? The lens is used in eye lens only. What about the mirrors? The mirror should be concave. It should be of large focal length. What about the convex mirror? It is just used as a reflector, not much more used. Now, what about the applications? Applications of TIR, which is very important. Total internal reflection is very applicable in several optical instruments like optical fiber. It is having two layers. It is used for optical communication. When light ray entering in it will get multiple reflection by TIR and pass through. This works on the basis of TIR. Mirage and armirage are examples of TIR. In the case of deserts, we see the reverse images of plants and trees, which is mirage, and in the oceans, the reverse images of ships are seen in the sky, which are unmirage. This is very important fact about the TIR. In a particular condition, a prism can also behave like doing TIR when kept in the way as I am showing in diagram. Then the light ray will get returning. This is also a TIR. Other question, on what principle diamond glitter? The glittering of diamond is due to total internal reflection. These were questions based upon optics. These questions are very important for upcoming Airforce examination. So all the best for all the students, and I hope you have enjoyed my video, and just do subscribe, like and share. Thank you very much.